Hello there. Welcome to my first video in my series Matlab, the basic basics. Now this video starts you off assuming you know nothing at all about Matlab and introduces you on Matlab's very basic operations. The other videos in this series will go through more elaborate operations, different types of computations, and different types of usages you can have of Matlab and the functions in Matlab. But this video just gets you started, shows you just how to get things going from the very beginning, and what elementary calculator style usage Matlab has at its most basic elementary level. Well, rather than delay any farther, let's get down to basics. So, if you look at a desktop, we have this desktop right here. What's the first thing I do? Well, I open up Matlab. Now, if you're working on a university computer, presumably they'll have an icon like this somewhere, or some sort of menu option to choose to activate Matlab once you've logged into the system. And you'll see a loading screen much like this. There we go. And there's Matlab up and running. Now, once I've opened up the window for Matlab, let's take a look what each window does. We have 4 windows right now: the workspace, the command window, the current folder, and down here, the details window. What do each of these windows actually do? Well, the current folder keeps track of what directory you're working in. If you have saved files from other work in Matlab, you will see, as here, that there are files. And if you single click on these files, what you see down below is a list of what's in each of these individual files. Now again, we'll focus on this in our video on scripts and workplace files later on in the series. For now, let's just put that aside. On the other side, what we're looking at, way over on the other side over there, is the workspace window. As you'll see in a few moments, the workspace window keeps track of all the values that are being saved into active memory. As we do our computations, anything that the computer retains numerically is displayed right there in that workspace window. So we can sort of peek inside to see what Matlab is doing with our numbers. And over here in the middle, we have our command window. And that's where we can type in commands to be executed immediately, very much in the same way you would use a basic calculator. Now, fair warning, you may, depending on what you've been doing with the Matlab previously, or if you're using the university computers, what was done with the Matlab previously, you may have another window here instead. Let me open that up. The editor window. Typically, the editor window appears at this location, but not necessarily at this location. It might be on the right, it might be on the left. If you have the editor window, we'll deal with that again in our video on scripts. For now, just close that window by hitting the little X, close editor, and let the command window, our topic for today, dominate the screen. Now, how does arithmetic work in Matlab? How do we use Matlab at its most basic level? Well, remember, Matlab is not just a glorified calculator. It's a whole programming language. But at this basic level, we can type in commands just like you would on any old standard code calculator you buy at the corner store. 5 plus 2 equals 7. 6 minus 8 equals -2. Multiplication, 2 times 3, we use an asterisk for multiplication, is 6. And we can do division. 6 divided by 2, of course, is 3. Now be a little careful. Matlab has 2 different types of division. I can do 6 divided by 2, but I can also do the opposite slash, which gives you 6 dividing 2. And of course, that would be 2/6, which is 0.333 repeating, 1/3. We can also do exponentiation. For instance, what's 2 to the 3? That's symbolically, that's 2 circumflex hat 3. And that gives us, in this case, 8, of course. So all your basic arithmetic operators are present here in MATLAB, just like you'd expect. Must point out something about that, though. If I do something like 5 divided by 58, notice we have a decimal 0.0862. Nice short little decimal. Now it turns out MATLAB is not just keeping 4 decimal places. MATLAB keeps an awful lot more decimal places than that. And you can see it if we temporarily do something called changing the format. There's a command, format long, which shows us how long, or should I say, it shows us all the decimal places that MATLAB is retaining. So in this case, 5 over 58 has a very high number of decimal places being retained. If I go format short and go back, we're back to 4 decimal places. Now it's not just retaining those 4 decimal places and displaying, it's actually changing the display as we do this. Either way around, we are keeping actually all those decimal values. Now, of course, rather than just using this as a straight-up calculator, we can also start talking about saving variables and saving the data. We can already see a little bit of this now. When I did 5 over 58, it said answer equals the decimal value. If you look over in that workspace there, you've been seeing that every time we do a calculation, answers assign the decimal value of the calculation we're doing. And we can use the answer value as a variable, as a name in further calculations. So since 5 over 58 was 0.0862, so forth and so on, I can do, say, answer divided by 2, and we'll divide that value by 2. As you'd expect, 0.0431. And then once it's done that calculation, it again assigns answer value to that new value. This is how variables work in MATLAB in general as well. If I type something like x equals 12, there, x has been assigned the value 12. I can also type something like y equals 6. Now y has been assigned the value 6. And of course I can do arithmetic with that. X plus y is 18. But be a little bit careful about how this works. If I say something like y equals, say, x over 4, I get 3. If I now go back and change x, it turns out y won't change. If x is now 27, we know that x over 3, of course, would be 9, and yet y is still 3. So the value doesn't change. Values are assigned by the equal sign. The equal sign sets the old variables and plugs that value into the new variable, which is very, very handy because you can use it to have the values of x, for instance, or any variable, updated by a computation. Right now we have x is 27. If I go x equals x plus 3, now what it takes is x, adds 3, and assigns that value as the new value for x. The equals here is an assignment equals. It sets the variable on the left to whatever the values are on the right. That's what's happening here. Now also notice, as I go through these computations, my x and y are appearing over and over again and changing in our workspace. And that indicates the current values of our variables, or at least a rounded off, simplified version as available to fit the given space display. I also want to point out something interesting. If we hit the up cursor, look what happens. All the commands we've done recently reappear. And I can go back up and select one of these and hit enter. Now we can't actually go and re-edit the stuff we have above in the command window, although we can copy and paste from it. But using this method of cursoring up, we can go back and recall and redo computations from before, or go up, select them, and then edit them. and give a nice result. So that's how the basic arithmetic works. But recognize there are a lot of calculator type operations you might want to do that are beyond adding, subtracting, and dividing. So what are we talking about there? Well, things like, for instance, here's our x. What's the SQRT of x? SQRT represents the square root, and that gives us some decimal value. Similarly, there's commands like ABS, which takes absolute value. There's statements like EXP, which takes e to the value. So EXP1, of course, gives us our good old friend, the Euler's number e. EXP2 would give you e squared. EXP3 would give you e cubed, so forth and so on. The reverse of this, the natural logarithm, we often call ln, Matlab notates as log, like most higher mathematicians. So log of that previous answer, surprise, surprise, is 1, because log of e should give us 1, or more appropriately for our in-class commentary, ln of e is 1. So that's how those are implemented. And all your functions appear like that. For instance, I can talk about sine. If I want to do sine of, say, pi. Now, pi is pi. In order to get the value of pi, let's do that first. We just type pi, lowercase. And again, there are more values, more digits available there that you don't see. It actually keeps it to as many digits as we saw before. Oops, typographic error. There we go, quite a few digits. And if we take sine of pi, let's go through. Let's do cos of pi. There we go. -1, as expected. How about tan of pi over 4? Tan of 45 degrees, pi over 4 is 1. All our trig functions are in radians. And if we take the inverse of tan, we have to use a tan. Inverse of cos, a cos. Inverse of sine, a sine. Now notice, we're not talking about cosine or sine or tan written with a -1. The -1 exponential notation we see in textbooks is fine for working by hand. But in Matlab, inverse cosine, sine, and all the inverse trig are implemented by putting an a in front of the function. So for instance, if I said a cos of 1/2, I should have the angle between 0 and pi, whose cosine is 1/2. Let's check. I'll take that answer and divide it by pi. There we go, 1/3, as expected. Now, there's one thing you should be really, really careful about. What if I were to type cos of pi? I get -1. But what's sine of pi? Ooh, what happened? Well, we know that sine of pi is in fact 0. So what's happened here is that Matlab has looked at sine of pi and said it's 0 under my calculation, but when I do my calculation, it doesn't quite round off properly. So I don't get exactly 0. Instead, I get a very tiny number. Now, how is this thing with an e in it a very tiny number? Well, this is what's called scientific notation. So the idea behind scientific notation is you have something with a number like 1.2246, where the decimal is right after the first number, and then you multiply it by some power of 10, and say 10 to the power of -16. And notice by typing in that, decimal times 10 to the exponent, that's exactly what I get. I get decimal e -1/6. The scientific notation it uses to return for very, very small numbers or very, very big numbers. If I wanted to do 50 times 10 to the 48, That, of course, comes out as 5.0 times 10 to the 49, E49. Remember, it puts that decimal place after the first integer, so that's why it's 5.0 to the 49 and not 50 e to the E48. So watch out and be careful about that. Now, one last little detail to worry about. Notice that we have all these numbers going around back and forth, all these computations. What if I want to do several computations in a row? Say x equals 2, y equals 7, and then say sine of x times y plus 3. Boom. If I put commas between the commands, it separates each command and computes them one at a time. X equals 2, y equals 7, then compute the sine. If I put semicolons in, instead of commas, it actually sets x equals 2, it sets y equals 7, and then computes the sine in exactly the same way as before, but it only displays the last answer. The semicolon hides the display. You can really see that if I change the numbers. Notice I use my arrow operation to go back one line, and I'm going to repeat that same operation with new values for x and y. Boom. Notice in my workspace, x and y have changed values, and I've only displayed in my command window the final computation of our sine. Furthermore, if I do it again, x equals 12, y equals 0, and furthermore I put a semicolon at the end, now nothing is displayed. But notice up in the workspace, x has changed, y has changed, and answer has changed. And in fact, if I now were to do something like 2 times answer, it multiplies that number, 0.1411, by 2, as you'd expect. So semicolons and commas are nice ways to organize your calculations in the computation, to put multiple ones in a line, to hide or display the results. Now notice too, semicolons and commas are used for something else in Matlab, which is very important, which you'll see in the video on matrices. So don't think this is the only role this has. And remember too, Matlab is called Matlab because it loves matrices. So when you're done here, go take a look at my video on matrix arithmetic, because matrices are really where it's at in Matlab, and where Matlab really, really begins to shine as a piece of software. After all, everything we've done so far you could do with a calculator. There's nothing special. But in the following videos, you're going to start seeing some of the real power Matlab has, not only to work with matrices, but to produce complex code and to produce functions and logical operations and all sorts of wonderful things that will help you not just to do basic arithmetic, but in everything you want to do in sciences and engineering. That's the end of us for now. Good luck with your Matlab.